Welcome to Space Nexus. Please subscribe and hit the bell icon for more breaking updates. Imagine a tiny, lonely traveler hurtling through the vast, silent darkness between the stars. Out there, in the endless void, it drifts further from home with every passing second. A solitary ambassador from our small blue planet. For nearly half a century, Voyager 2 has been our eyes and ears in the cosmic ocean, sending back postcards from worlds we once only dreamed of. It has revealed the secrets of Jupiter's storms, Saturn's rings, and the icy moons of Uranus and Neptune, expanding our understanding of the solar system in ways we never imagined. It carries a golden record, a message in a bottle for any distant civilization, a greeting from Earth. This record holds the sounds of our planet, music, greetings in dozens of languages, and images of life on Earth, a hopeful gesture that we are not alone in the universe. This machine, a testament to human curiosity, has traveled farther and seen more than any other. It has ventured beyond the influence of our sun, into the uncharted territory of interstellar space, carrying with it the dreams and ambitions of generations. But now on November 10th, 2025, we reach a poignant crossroads. The mission that began in the 1970s is entering its final chapter, and we must prepare to say goodbye to our distant explorer. The faint whisper from Voyager 2 is fading, not by accident, but by our own design. Its signal, once strong and clear, now struggles to reach us across the vast gulf of space, a reminder of the limits of even our greatest achievements. Its nuclear heart is growing cold, and to prolong its final watch, we must begin shutting down its instruments. Each system we turn off is a farewell to another chapter of discovery, a necessary sacrifice to keep the mission alive just a little longer. This is more than a technical decision, it's a moment that touches the core of our identity as explorers. It's a bittersweet reminder that every journey, no matter how grand, must eventually come to an end. Voyager 2 is a symbol of our relentless drive to understand the universe. It represents the courage to venture into the unknown, to ask questions, and to seek answers beyond the horizon. As its voice dims, we celebrate its astonishing legacy. A story not just about a machine, but about the enduring power of the human spirit to explore and inspire. Voyager 2's journey reminds us that our curiosity knows no bounds, and that even as one chapter closes, the quest for knowledge continues. Let's travel back to 1977, a moment of rare planetary alignment. Jupiter, Saturn, Uranus, and Neptune lined up, allowing a single spacecraft to visit them all using gravity assists, a grand tour. NASA seized the opportunity, launching twin spacecraft, Voyager 1 and Voyager 2. Voyager 2, built with 1970s technology, was designed to endure the harshness of deep space. Its mission to unveil the mysteries of the gas giants and their moons, using a suite of cameras, spectrometers, and detectors. Powered by a nuclear battery, it could operate far from the sun, where solar panels would fail. Attached to its side, the Golden Record, a time capsule of Earth's sights, sounds, and greetings in 55 languages. Carl Sagan called it a bottle launched into the cosmic ocean, a message of peace and curiosity. Voyager 2 set out not just to explore, but to represent humanity to the stars. Voyager 2's grand tour began in 1979 with a historic flyby of Jupiter, the largest planet in our solar system. As it soared past, Voyager 2 captured breathtaking images of the swirling Great Red Spot, a gigantic storm larger than Earth that has raged for centuries. The spacecraft also revealed the dramatic volcanic activity on Io, Jupiter's innermost large moon, where plumes of sulfur and lava erupted hundreds of kilometers into space. These discoveries transformed our view of Jupiter from a seemingly static gas giant into a dynamic, violent system teeming with storms and geological activity. In 1981, Voyager 2 reached Saturn, the jewel of the solar system, and began an in-depth study of its magnificent rings and mysterious moons, capturing details never before seen by human eyes. Voyager 2 discovered strange and intricate ring structures, including spokes and braids that puzzled scientists. It also examined Titan's thick, hazy atmosphere, hinting at the possibility of complex organic chemistry beneath its clouds. After Saturn, Voyager 2 ventured into uncharted territory, Uranus in 1986, becoming the first spacecraft to visit this distant icy world. Voyager 2 found a tilted, aquamarine planet with a bizarre, off-center magnetic field, 11 previously unknown moons, and 2 new, faint rings circling the planet. The encounter was brief but revolutionary, transforming Uranus from a distant, featureless dot into a fascinating and complex planetary system. In 1989, Voyager 2 became the first, and so far only, probe to visit Neptune, the most distant giant in our solar system. It discovered the mysterious, Great Dark Spot, a massive storm system swirling across Neptune's blue atmosphere, and measured the fastest winds in the solar system, racing at over 2,000 kilometers per hour. Voyager 2 also revealed Triton's nitrogen ice volcanoes, geysers erupting from its frozen surface into the thin atmosphere. Each flyby rewrote textbooks, unveiling new mysteries and deepening our understanding of the outer planets and their moons. Voyager 2's planetary tour remains unmatched, a feat of navigation, engineering, and scientific endurance that continues to inspire. Its journey beyond the giants marked the start of a new chapter, the Interstellar mission, as Voyager 2 sailed onward into the unknown, carrying humanity's curiosity to the stars. After its historic encounter with Neptune, Voyager 2 set its sights on a far more distant frontier, the very edge of our solar system. This boundary, known as the heliopause, marks the place where the sun's influence finally fades and the vast unknown of interstellar space begins. For decades, Voyager 2 pressed onward, venturing through the cold, dark reaches beyond the planets. Its mission, to measure the outer heliosphere, study the solar wind's limits, and search for the elusive boundary where our sun's protective bubble ends and the galaxy's domain takes over. On November 5, 2018, after more than 41 years in flight and a journey of over 18 billion kilometers, Voyager 2 finally crossed the heliopause. It became only the second human-made object to enter interstellar space. Its instruments recorded a dramatic drop in solar wind particles and a sudden increase in cosmic rays, clear signs that Voyager 2 had left the sun's domain and entered the realm between the stars. This achievement marked a profound milestone for humanity. With 2 active probes now beyond the sun's reach, we had become, for the first time, an interstellar species, our robotic explorers venturing where no one had gone before. Voyager 2's plasma science instrument delivered the first direct measurements of interstellar plasma, revealing it to be denser and colder than the plasma inside the heliosphere, and offering new clues about the nature of the space between stars. The data Voyager 2 sends back is invaluable, providing a window into the mysterious environment our solar system is moving through as it orbits the galaxy. In many ways, Voyager 2 now serves as a weather station for the interstellar medium, helping scientists understand the forces that shape stars, galaxies, and the evolution of the cosmos itself. Every packet of data it transmits is a precious gem from the void, a message from the frontier that expands our knowledge and inspires our imagination. Voyager 2 is not just visiting the stars, it's teaching us what it means to live among them, and reminding us how far human curiosity and ingenuity can reach. Voyager's longevity is thanks to its plutonium power source, but that power is fading. Each year, the output drops, forcing NASA engineers to make tough choices about what to keep running. The strategy sacrificed some instruments to extend the mission's life. This means shutting down non-essential systems and, eventually, the scientific instruments themselves. In 2023, the heater for the plasma science experiment was turned off, a risky but necessary move. In 2024, the low-energy charge particle instrument was shut down. Each decision is a calculated sacrifice, balancing the mission's lifespan against scientific return. The team's ingenuity allows them to control a 1970 spacecraft from over 20 billion kilometers away. Every extra day of data is a victory against the inevitable silence. The mission's end is coming, but each moment is stretched as far as possible. Each instrument shut down on Voyager 2 is a loss, a unique sense gone forever. The plasma science experiment let us directly sample the interstellar plasma. Without it, we're blind to the fine details of the cosmic wind. The low-energy charged particle instrument helped us understand how the solar wind interacts with the interstellar medium. Losing these tools narrows our view, like hearing an orchestra with missing instruments. Our models of the heliosphere and cosmic rays become less certain as data sources vanish. Some questions about our cosmic neighborhood may now go unanswered for generations, yet the mission isn't over. Instruments like the magnetometer and cosmic ray subsystem still provide crucial data. The story now is one of focus, extracting every last drop of knowledge from what remains. Each final transmission is a cherished gift from the void. Communicating with Voyager 2, over 20 billion kilometers away, is a technical marvel. A radio signal takes more than 19 hours to reach it. A command and response cycle spans nearly 2 days. Engineers must anticipate problems and craft solutions for a spacecraft whose true state is always hours out of date. When Voyager 1 sent back gibberish in 2023, the team diagnosed and fixed the issue remotely, an astonishing feat. Every command to Voyager 2 is meticulously planned and tested, ensuring no unintended consequences. The mission's success is a testament to the value of long-term investment in science and technology. Lessons learned from Voyager shape current and future missions. The faint echoes we receive are reminders that with ingenuity, we can overcome even astronomical distances. Voyager is more than a scientific mission, it's a cultural icon that reshaped our view of the universe. Its images, Jupiter's clouds, Saturn's rings, the pale blue dot, are moments of collective wonder. The pale blue dot, a single pixel in the vastness, reminds us of our shared humanity and the fragility of our world. Voyager's story has inspired generations to pursue science and exploration. It proves we can build things that last and embark on journeys that span generations. As Voyager 2 fades, its legacy grows, a monument to curiosity and the human spirit. It's our signature in the starlight, a testament to a species that dared to look up and venture out. The silencing of Voyager 2 is not an end, but a transition. It closes one chapter and compels us to ask, what comes next? The questions that drove Voyager, are we alone? What is our place in the galaxy? Remain as urgent as ever. Voyager's legacy is a call to action for the next generation of explorers. Future missions like the Interstellar probe will build on its achievements with new technology. Supporting these endeavors is our responsibility. By staying curious, sharing discoveries, and advocating for science, the universe is accessible to everyone. Wonder begins with looking up. By valuing knowledge and discovery, we lay the groundwork for the next great missions. Voyager 2's story is one of hope, a fragile craft, built by hopeful people, whispering across the void. As we listen to its final messages, let's be inspired to continue our journey to the stars. The cosmos awaits.